Alright, for section 5.2 we are building on what we've learned in 5.1, hopefully getting better at doing the factoring, recognizing when to get common denominators, when to multiply by conjugates, and that sort of thing. So I'm going to do just some more verifying problems. As you know, it's the same thing as what we did in section 1, only now they tell you what the answer is. And so just a reminder, you are supposed to leave the right side alone. You're not allowed to work with it, or you're not supposed to do anything with it. So I have to try to make the left side look like the right side. So basically simplify this into that. Again, I'm looking for specific things, and it's always different from problem to problem, but what jumps out at me is the fact that I have one term here, and suddenly I have two over here, which means when I see that cotangent squared, that tells me I probably want to switch that into something with two terms. So I probably want to use one of my identities here. So I'm going to need to pull out my identity sheet if I don't remember what the Pythagorean identities are, and look for the one that has cotangent squared in it. And you will see, if you look it up, that it is cosecant squared minus 1. So I'm changing cotangent squared x into cosecant squared x minus 1. It probably jumped out at you the fact that you saw that to begin with. Said, would sines and cosines work? Yes, but that should be a last resort option. I would not do that until you absolutely have to. Basically, in other words, if everything else fails. Alright, once I've got that, okay, remember what we said, I need two terms. I've got two terms divided by one term. Why not break these apart and say that this is the cosecant squared of x over cosecant of x minus 1 over cosecant of x. Now when I look at it, say, okay, good, I've got two terms, that's good, I want that. Well, look what happens if you simplify. Cosecant squared over cosecant gives you just cosecant x, of course you want that. 1 over cosecant is actually sine. I actually got what I'm looking for. And it's amazing how complicated a problem like this exact problem can be if you don't recognize to do that right away. And then it's amazing how easy it can be if you do see that. And like I said, that's what comes with experience, and you're probably getting a little bit better at doing it. By the time we're done with this section and section 3 in the chapter in general, you'll be a lot better at identifying what to do. Alright, as long as you keep giving it your best effort and don't get frustrated. Alright, so the next one, verify cosecant x minus sine x equals cosine x times cotangent x. I don't see any squares. There's no specific identity that jumps out at me. What does jump out at me, though, I have two terms. My answer is only one term. That means I probably need to get a common denominator. So I can change this, of course, into 1 over sine x minus sine x. And then I'm going to multiply this by sine x over sine x so that I have the common denominator I'm looking for. And how do I know to do this? Why do I know to do this? Because I have two terms, the final answer has 1. So I know I have to get a common denominator at some point. Alright, so now I've got the common denominator of the sine of x. If I look at the numerator, I have 1 minus sine squared. Alright, I want to keep this all as one term, so chances are I don't want those two. I want to combine them into one, and because it's 1 minus sine squared, hopefully by now I can identify that to be cosine squared. So now I've got cosine squared over sine. And again, pay attention to what the answer is, because it's going to guide you in terms of making a decision. Look at what you want for an answer, and look at what you have. You want to have one cosine. Well, I've got two of them, so could I break it up and say I've got cosine x, sine x? There, I've got the one cosine that I had up here. Now I need a cotangent. Sure enough, that is cotangent. So now I can say that, yep, I've got cosine x, cotangent x. I am done. Now, you probably, once you get to here, especially when you start getting really good at this, once you get here, you can probably see that, yep, I'm switching that to cosine squared. Yep, I know I can break those apart and get that, but I do not want you to write this and then that. There's too many steps in there that I don't know what you're doing. Even though you might be thinking 100% correctly, I can't see what you're thinking. So I don't know if you got lucky, I don't know if you guessed, I don't know if someone told you the answer and you just happened to write it down. Not that I think you did that, but I need to see your work is what I'm trying to say. All right, looking at the third one. Verifying this one is equal to that. All right, this one's actually very quick and easy, but I'm going to show you a very long process. And the reason I'm doing that is this problem is very similar to what you're going to have to do for number 30. And for number 30, it won't work out quick like this one will. All right, I'll show you the quick little process, and then I'll show you the long drawn-out process that'll help you with number 30. The quick little process, I noticed that the numerator, two things, doesn't really matter how many things. Two things up here, two things here, that's good. I noticed the denominator is only one thing. That means I can break the numerator apart. So I'm going to say that this is the tangent of x over tangent x cotangent y plus the cotangent of y divided by tangent x cotangent y. And then if I look at that, I'd say, well, wait a minute, the tangent x is just cancel. I'm going to have 1 over the cotangent of y, which of course would change into the tangent of y, which is exactly what I want, plus the cotangents cancel, and I end up with 1 over tangent x, which is of course cotangent x. And I have what I want. Fairly quick and simple, just recognizing that I already had two terms in the numerator, one term in the denominator, so go ahead and split them apart. Now, the problem number, the number 30, the one that you actually have for homework, you have a 1 minus or something like that, so you don't have one specific term. You have two of them. Of course, you can get a common denominator and combine them, and that's eventually what you'll want to do. All right, so here's what I'm going to show you. Yes, if you do that, that's fine. That's what I would suggest you do. But here's another way of doing this problem, and you kind of want to do the same thing. I'm going to change everything into sine and cosine. So I'm going to change tangent x into sine x over cosine x. I'm going to change cotangent y into cosine y, I guess that is, over sine y. And then my denominator, I'm going to change this into sine x over cosine x times cosine y over sine y. And then I see I've got a complex fraction. It would be lovely if I could multiply by the reciprocal. And before I do that, that means I have to have common denominator here. So it would be really nice if they all had the same common denominator. So I'm going to make sure that all of these denominators look like this. So I'm going to have to multiply this one by cosine x over cosine x, and this one by sine y over sine y. Alright, so my next step down here is going to be sine x sine y plus cosine y cosine x, doesn't matter the order that you write them, they're being multiplied, divided by the common denominator of cosine x sine y. And then that's divided by sine x cosine y over cosine x sine y. Now when I go to multiply by the reciprocal, the cosine x and the sine y will go to the numerator, and this sine x cosine y will go in the denominator. Those completely cancel, and now I have kind of the same scenario. I have two terms divided by one term, so I'm going to break them apart. And I'm going to say that this sine x sine y is now divided by sine x cosine y, plus this numerator of cosine y cosine x is also divided by sine x cosine y. So kind of backing up, splitting it all into sines and cosines, getting a common denominator so that I could multiply by the reciprocal. Now that I have multiplied by the reciprocal, I've split them up, and if you look at these closely, you can see that the sine x's cancel and the cosines y cancel. And then look what you have. You have sine y over cosine y, which will change into tangent y. You have cosine x over sine x, which will change into cosine x. And so all you need to do is show me these canceling out and then go ahead and actually write out tangent y plus cotangent x. And you're done. A little bit tricky. Like I said, this is how I would actually solve it. This is how you might want to do, this is the idea you're going to want to use when you're doing number 30. And we'll still have a chance to look at it in class if you need to. Last one's going to be another verifying problem, like this whole section is. it gives us secant to the fourth times tangent squared x is equal to this. Remember, you're supposed to leave the right side alone. You're not supposed to do anything with it. You're supposed to take the left side and get it to look like the right. Doesn't mean you can't look over here and get ideas. So for example, I know in my final answer I need to have a secant squared. Well, I've got 4 of them. I don't want 4 of them. I only want 2 of them. So that kind of clues me in to say, well, change this to secant squared. That's what you want. And then whatever you have left, it just so happens to be another secant squared. Still have that tangent squared. So if this was secant to the third, I would say secant to the third and then secant. Or secant to the fifth and then secant, depending on what this is. So now I've got that part, which means this must be coming from here. So these are both tangents. That's not tangent. That clues me in to say, hey, use an identity and switch that to something with tangent. So I know that secant squared is equal to tangent squared plus 1. So I'm going to make that substitution. So writing that out, I've got secant squared here. I'm changing this to tangent squared plus 1, and then I still have that other tangent squared there. So again, leaving this alone because it's part of my answer, I now have nothing but tangents, which is good, and if you take a second look, you can see if you distribute, you will get exactly what you're looking for. And so I'll rearrange the order so that it's exactly what they want, but order really doesn't make much difference. It's tangent to the fourth x plus tangent squared x times secant squared x. And now I've got it. So even though you're not supposed to do anything actually like distributing or doing anything like that, nothing's saying that you can't look at this and get clues. Like when I look at this and say, oh, I've got 2 terms. Or when I did this problem and said, oh, I've only got 1 term, but I had 2 terms here, that's a clue. Get a common denominator. Hopefully that'll help you out for section 5.2.